Hello, and welcome to Nexperia's Power Up Insights, where we talk about PowerPath products. Today we'll be talking about the NID5100 Integrated Ideal Diode. The NID5100 is a low-leakage integrated solution for traditional Schottky diodes. It is offered in a TSOP6 package and supports currents of up to 1.5 amps. In power chain designs, ideal diodes are typically placed at the power input to provide protection similar to a traditional diode. The NID5100 can also be used in a wide array of applications requiring multiple power supply inputs. In this scenario, a dual supply is powering a downstream load via a wall supply and an external battery that is installed backwards. To protect the system, the bottom NID5100 disconnects the pass FET to prevent damage from the reverse polarity condition. A combination of ideal diodes and conventional diodes can also be implemented if voltage drop is not a concern. In this scenario, an AC to DC adapter is the primary source of power supplying 5 volts to the system. If the AC to DC supply loses power or is disconnected, the 3 alkaline batteries will begin to provide power to the system. The NID5100 can also be configured in parallel to sustain high currents and maintain thermal efficiency. This sharing of the load current can lead to lower internal power dissipation in system designs. As with priority ORing, there is no limitation to the amount of devices that can be used in parallel or ORing configuration. Now let's take a look at some of the key features and benefits of the NID5100. The input voltage operating range is 1.2 to 5.5 volts. The NID5100 also has reverse voltage protection up to -6 volts at Vin. This prevents reverse polarity conditions from damaging any of the devices connected at the NID's output. The forward voltage drop of the NID5100 is about 31 millivolts at Vin equals 3.3 volts. This allows for lower power dissipation and better temperature stability. This device utilizes an open drain status pin that is high when the NID5100 is enabled and in forward conduction, and low when disabled or in a reverse biased condition. At Vin equals 3.3 volts, the typical shutdown current is 170 nanoamps and the typical quiescent current is 240 nanoamps. Compared to the competition, the NID5100 offers best-in-class forward conduction voltage, peak reverse current, reverse DC leakage, a competitive maximum continuous current, along with the ability to OR and parallel an infinite number of devices. Compared to a traditional Schottky diode, the NID5100 offers superior thermal performance, forward voltage drop, reverse leakage, and maximum continuous current. The NID5100 can be used in a variety of spaces, including industrial and consumer products that use ORed primary and backup power, battery-powered wearables, and smart metering. In the automotive space, the NID5100 can be used in ADAS, automotive cluster displays, and body control modules. Thank you for watching this Power Up Insights on the NID5100. If you'd like to learn more about the NID5100, please visit nexperia.com.